Now, if you see entry points, broadly there are, like, we can classify total network theory into two. That is network theory or circuit theory. Okay, and one more thing is, of course, it is nonsense question, I know, but in some interviews they ask. That's why I'm telling you here. What is the difference between circuit and network? Okay, circuit and network. That is very funny thing to ask, because the reason also I'll tell you at the end. For example, if I have maybe whatever it may be, big network like this, okay, at least one closed path is there, no? See, at least one closed path is there. So, means only I'm telling you for the interview purpose only, because it is a wide question. At the end, I'll tell you that. Okay. See, the moment you have at least one closed circuit, that can be called as circuit. Okay. And if you don't have any closed circuits, it can be called as network theory. Okay. For example, closed paths are not there. I'll tell you why this is wide also. Like this. Okay. Is there any closed path here? No. There is no closed path. So the moment closed paths are not there, we can call this as network. Basically, network is superset of circuit. Okay, because means circuit in the sense at least one closed path should be there, and here network in the sense open path also. But why this question is wide? Okay, not good question. Okay, but of course people are asking, because if you have all open circuits, in the sense if you don't have even a single closed path also, what is the purpose of having that circuit? Okay, so for example, all open circuits are there, voltages may be there, current will not flow, energy transfer will not happen, power transfer will not happen, nothing will happen. Under that conditions, will there be any physically existing system without having any single closed path also? Okay, because energy transformation will not happen. Okay, so anyway, that is the difference between network and circuit. Now, coming to the point, what are the entry points? Broadly, means I'm going to use from now onwards circuit theory or network analysis or circuit analysis in the similar way. Now, first of all, the circuit theory or network theory can be broadly classified into two subsections. Okay, the first subsection is going to be analysis, and I'll tell you why analysis only questions can be expected. Okay, and another one is going to be synthesis. Okay, analysis means that for a physically existing system, mathematical model will be given. Okay, for a physically existing electrical system, we are electrical engineers, guys. We think everything from electrical line only. Okay, now point here is, for any physically existing electrical system, if mathematical model is given, and that what you are supposed to do, maybe I'll ask, means the particular other may ask you, maybe our Hythe and Kimberly may ask you, at this particular voltage, how much is the current? Or at this particular voltage, or at this particular current, how much is the power absorption, how much is the power delivery, some kind of stuff they can ask. Okay, but mathematical model is given, no circuit is given to you, no. That is analysis. Okay, now in analysis, the advantage of analysis are why that analysis is only there in our GATE syllabus. Or previously synthesis used to be there in ESE syllabus, but now they remove that also. The reasons I'll tell you. In analysis, meaning that our physically existing system mathematical model will be given. In the sense, some circuit will be given. Upon that circuit, you have to apply mesh analysis, nodal analysis, or kind of theorems or whatever it may be. But whatever may be the tool you use, you are going to get unique solution. Unique solution you are going to get. Okay, so if you have unique solution, obviously questions can be asked in ABCD, right? And options they can give. But if you think of synthesis, okay, in synthesis, the problem here is, let me take, of course, about what is a capacitor, what is a resistor, and all. We will see later, not a problem. Okay, but overall look, you know. So in order to understand synthesis, I'm taking this example. That's it. Okay. Now, for example, here some source is there with variable frequency. Okay. So with variable frequency, frequency is variable here. Okay, if I keep on increase frequency, for example, if I apply zero frequency, meaning that DC, if I apply DC, capacitor is going to be open circuited. Okay, if capacitor is open circuited, whatever will be the voltage, directly that voltage will come. Now, if you keep on increase frequency, what will happen? Of course, don't focus on capacitor now, because we have to build basics. No, somewhere we have to start. Now, if you keep on increase frequency, reactance of this will keep on reduce. Assume that I have applied infinite frequency, for example. The moment infinite frequency, my capacitance will behave like short circuit. Right? Capacitance will behave like short circuit. So for infinite frequency, because reactance is inversely proportional to frequency, later we will say. So at a very high frequency, it is going to be short circuited. Kind of reactance will be keep on reducing if you keep on increase frequency. At that point, how much will be the voltage? Voltage is going to be reduced. So at low frequencies, input voltage will be output. And if you keep on increase frequencies, output voltage is going to keep on reduce. Right? This is low pass filter. Low pass filter. Okay. Now same low pass filter, can I build in another way? Okay. So same low pass filter, if you want to build in another way, I will erase this. No, it should be there. Okay, I'll draw here. Okay. So for example, if I have inductor, resistor, let us analyze this. Again, frequency is variable. Okay. So again, frequency is variable here. Then what will happen? For example, frequency is 0, low frequency. At low frequency, what will happen? Our inductor behave like a short circuit, DC. Okay. So the moment inductor is kind of short circuit, means total input voltage will become output voltage. Right? Now, if you keep on increase frequency, reactance of this will be increased. Okay. For example, kind of infinite frequency, kind of. This is very, very high frequency. At very, very high frequency or infinite frequencies, it is going to behave like an open circuit. Okay, so the moment it is open circuit, how much will be the output voltage is going to be 0. Okay, so at low frequencies, it is behaving like a short circuit and input voltage will become output voltage. And if you keep on increase frequencies, reactance offered by this will keep on increase. So because of that, output voltage will keep on reduce. For low frequencies, high output. For high frequencies, low output. Meaning that it is also low pass filter only. It is also low pass filter only. Okay. So this is design. Okay. Now that design will come under synthesis. Okay. If you want to create any new thing, if you have already physically existing system, we are going to convert that physically existing system to mathematical model by conducting some tests on the physically existing system. And once that mathematical model we got, we are going to apply something in the mathematical model only. We are not going to go back to physical existing system, that is analysis. Now, you don't have physical existing system. You have to design physically existing system. So the moment design, obviously for a designer, many options will be there, right? So means either in this way also low pass filter can be designed, or in this way also low pass filter can be designed. Getting the point, right? Now, that's why for synthesis, the moment it is designed, of course, there are some forms, Foster form, Cowell form. When I attempted ESE, those courses used to be there. Okay. In ESE, that too in descriptive only, because unique solution is not possible. Okay. Here for synthesis, multiple solutions will be there. Multiple solutions will be there. So that's why they cannot keep it in ABCD options. Okay, objective. They can keep these questions only for descriptive. But here in analysis, so our main focus is network analysis or circuit analysis, because I told you simultaneously I can use network or circuit. Okay. Now this is going to be the entry point. Our main focus from now onwards is analysis.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.